build data sets for specific cultivars, I recommend that you do about 3 or 4 testing with leaf tissue analysis, soil testing, with the saturated paste and sap analysis, because you can build an entire nutrient profile and map that out with this type of data for specific cultivars. So if you know that you want to grow, sour diesel, and that is one thing that you want to maximize the quality and the yield, but you need to figure out what the nutritional values for that look like, then this is how you do it. You can map it out with agronomic data. If you're not in beds, and let's say you're in a smaller system, you may have to test more frequently depending on the size, because the smaller size pots don't hold nutrition as long. And so what ends up happening is the bigger your plant goes, it uses more of that nutrition, and you'll have to reapply some of the things like calcium, magnesium, nitrogen, potassium. Those are 4 of the elements that cannabis uses in abundance. I mean, the amount of calcium and magnesium and potassium that these things eat it's crazy. And so being able to monitor that's what you do. If you're in a 7 or 10 gallon pot, you might want to do like maybe 3 tests per run, and do while you're transitioning, and then maybe a couple weeks into flower. That way you hit all your targets.
Were you looking for to actually understand that the plant is how do you determine the target levels? Like once you have your numbers now.
Yeah, so the target numbers were developed by numbers that were actually in books, right? So there was an agronomist in the 1970s that mapped out all of the tissue targets for almost every single agriculture product plant that is farmed in the world. It's called the Plant Analysis Handbook, and it had these base targets. But when we're starting to look at cannabis, we know that calcium can't be at 1.75% to 2%. It has to be way higher than that. And so what we're looking at targets that were developed by our predecessors, and then we're building off of that, being able to use better science, better analytics, and more controlled environments when we're able to scale these things out and operate in a commercial setting. So it's a game changer, because I cultivated for 18 years in San Diego in the traditional market, and I was a good cultivator. I could grow great fucking weed. But when I got into the commercial side of things, and there was people that were just investors that were like, this is what we expect, then you have to make sure your shit does the same thing every fucking time. Because you can't be like, I don't know, and that's one of the big problems. It can be really difficult for people to transition. It's a different thing. I had to figure all of this out, really, really fast, and I had help along the way. I talked to a lot of other agronomists. I bounced off of ideas, but it was the act of doing it repetitively over and over, not just for myself, but for other people. That's helped make me way better than this. I talk to people at universities, and they're so far behind even on this, because they don't have the resources to do that. It's only people like myself or people like you guys that can go and collect independent data to make data sets like this that makes you guys selves valuable when things change,
Was this getting with gypsum and whatnot? You're saying you can get a bag that's 50 pounds bag or whatever. Probably they don't have heavy metals work. So you just go
That's an excellent question. So heavy metals in amendments. One of the things about the amendments is that most of this stuff does come from big companies. Regardless if you get it from another smaller company, the mines are usually owned. And there's usually only maybe gypsum. There's maybe 3 or 4 mines in the whole U.S. And so you can find mines that are more localized, but each one of those mines is going to be different. And each one of those mines is going to have a different metals level in it, right? And so you have to be able to figure out where those sources are as a company, and then it's my responsibility to go and test. Just like I do my soil. I have to test because I sell soil. And I cannot stake my reputation on building a soil that fails somebody for heavy metals, you know? They have to be able to pass that stuff. It's because, and it's my responsibility to do that. It only costs $10 at the University of Lafayette in Louisiana to test any amendment. And so that's what we do when we're building our soil. All the stuff that I have listed on my website, all that stuff is all heavy metals free because we find all the best sources so that we don't have to deal with that. Because I use this stuff too, you know. So that's one of the. It's a really good question, dude. Because a lot of these companies, man, they don't take the extra effort to go and make sure that you're getting a superior product.
With that, so let's say you're like front-loading like calcium and whatnot, and let's say some whatever percentage, and we're trying to make sure it doesn't get like locked up, like phosphorus or whatnot.
I put my back.
You can use these tests to find out how the organics are anything.
Yes. So that's one of the benefits is when you're constantly collecting analytics and it's part of your SOP, which is your standard operating procedure for your cultivation. When you're looking at calcium, because calcium, magnesium, and potassium, they're all cations, which means they're all positively charged. So they need to be in the right balance to be able to diffuse properly into the solution. So when you're looking at this, and we're looking at the percentage, you know, this isn't a great example, but we're looking at, you know, the percentage here. You know, like if we were going to go back to these targets over here, and we're looking at, you know, calcium, we want calcium at 55 to 60% of our total solution. Magnesium 17 to 19, potassium 15 to 18. This is for veg, you know. And so if you know this and you're looking at it from that standpoint, you're not going to have any antagonistic problems. And then if you're using the right biology to help cycle, one of the biggest myths in organic cultivation is that you can't yield what people do in synthetic, and it's not true. What happens is that phosphorus, which is a really, really important element, the phosphate molecule doesn't exist freely in nature. So as soon as it diffuses, or as soon as it is in solution, if it's not immediately taken up, it'll bond with things like calcium and that'll precipitate out of solution into like a calcium phosphate molecule, right? And so neither of those two, calcium or phosphorus molecules, are available. And so it doesn't, and so what we're looking at is when you have the right biology and you're able to continually cycle, because there are enzymes that will break those molecules together. So if you have enough in the system itself and you have the biology to help with that cycling process, that is one of the key factors to the yield potentials. Is because typically what I see, especially when I start off with new clients that are looking at these tests, their phosphorus levels are always really low, and then they're also usually having an issue with water, because a lot of people aren't testing water and they're getting high sodium, high bicarbonate, and high chloride levels in their water, and it's adding up in their systems over time, and it causes antagonistic relationships.
So let's say like how soon are not going to get let's say like the micro how you start receiving?
Yes, with the one of the benefits about microbiology is that you can't really overdo it, right? I mean, you can overdo it, but it really takes like a lot of extra effort, a lot of too much of doing something to overdo something like Micro Plus, because you can inoculate a seed. You know, you can take you know, the 30 milliliters, put that in a gallon of water, and sprout your seeds with it. You know, it's not going to have a negative impact because those things are beneficial. You know, trichoderma as well. Bacillus subtilis, trichoderma combo, they're gonna naturally outcompete pathogens in soil. But not only that, like iron is really tricky. If you look at any conventional fertilizer, iron is always chelated with a chemical chelation agent. And the reason is because it oxidizes in these systems so rapidly. that a lot of the iron that's put into these systems, it's not bioavailable. And what happens with the trichoderma is they create siderophores. They're secondary metabolites, and they chelate iron and keep it in its ferrous form that's available to the plant. And so when these things, populations increase, and they're able to sequester all this iron from the system, they tie it up in a form that's metabolically available for the plant. pH is highly dependent, especially when it comes to iron. The lower the pH, you'll have higher iron availability. However, a lot of other things don't work at those levels. So that's why using biology to slightly acidify your soil for a brief period in time can help with that's how it works, right? Because these things are creating organic acids and enzymes, and those are the things that are actually solubilizing and breaking down the mineral amendments and the organic material in that soil system, right? And so when you're adding in those bacteria that are producing those compounds, it creates a chemical reaction within that system, making a lot of that stuff bioavailable, like the phosphorus, like the zinc, like the micronutrients. You know, depending on the biology, sometimes nitrogen. That would take real-time analytics and testing, which we don't have the capabilities for. So, different nutrient sources, like where did I have to go through? I went through a lot. So when I'm looking at the nutrient profile, it's really dependent because we have things like potassium sulfate, which is a mineral sulfate, it's a natural rock mineral. But if my sulfur is already high, I don't want to add that in. So I might put something like calcium, potassium silicate instead, right? And that's going to bring in the potassium and the silica. And the same thing for like pH, right? If I'm looking at pH, I'll use wollastonite, which is calcium silica. And what that does is it increases and stabilizes the pH. And it brings in calcium. So if I need calcium and my pH is low, I'll just use wollastonite, especially if my sulfur is always high. So all of that is a balancing act. It's a really delicate balancing act, and that is like the key factors. There's a key to all of this. So I have a key, and I've built out a nutrient calculator where I just put that in the column, and I've already done all the math and algorithms for how much of what certain meal breaks down over what certain time, and how many parts per million of each element are broken down over that course of time. And I've been able to map that out on a digital calculator. And so that's one of the ways that I've made this a lot easier, because I used to do this all by hand on paper. And instead, I figured out how to do some math, which I thought I was terrible at. But once I have something to apply it to, it works really well. And so there's a key. I know that if I bring in 0.2 cups of calcium per yard of soil, it'll raise up the parts per million by 10. And I know what those targets are for every single element that is in that system. That's a good question, because this is a snapshot in time, because this isn't real time. You have to take a soil sample, you have to mail it to a lab, which usually takes 2 days, and then they take 5 days to get the results back to you. And so it could be better, it can be improved, and there will be, because we have things like metering systems that they measure our CO2, our pH, right? We have all of these metering systems, and soon we'll have ion-specific probes that'll tell us the amount of nitrate, the amount of ammonia, the amount of calcium, the amount of magnesium, the amount of potassium, the amount of sodium, all in real time. And what we'll be able to do is build out digital maps. So we'll have all of our environmental parameters, we'll have all of our soil parameters, and we can even put that into like blockchain, so that way we can just so people can see it and see like how, and after time you build up those data sets, and you just keep doing it, and you keep collecting data, and then you can start doing grafting to see like what correlates to what. like, at the end, if you know you have good harvest here and you want to replicate that, and something, you know, go and look at what change happened throughout that, and it's all mapped out for you already. I think I'm probably over my time, so I appreciate everybody that came out, that listened to me, and I'll be around here if you guys have any questions. I don't argue, unfortunately. I do have